idea that our universe may be entirely contained within a black hole is a mind-bending concept that has been explored by physicists for decades. It suggests that what we observe today is merely the interior of a black hole in another universe.
Oftentimes people think about black holes as these gargantuan structures that form from collapsed stars. There's a big one in the center of our Milky Way galaxy, weighs 4 million times that of the sun. The photograph of a black hole in the galaxy M87, 55 million light years away, billions of times the mass of the sun. But the reality is, anything, if you compress it enough, becomes a black hole. If you take an orange and you squash an orange down sufficiently small, according to Einstein, it becomes a black hole. These things don't have to be gargantuan. The flip side of it is, we also typically have an intuition that black holes are really dense, right? That's usually the way we think about them. But if you make something sufficiently large, regardless of how low its density is, it will also become a black hole. So you can make a black hole out of air by just having enough air. If you have enough air, sufficiently large sphere of air, it would become a black hole too.
This theory draws upon both general relativity and quantum mechanics, and could provide answers to some of the most perplexing questions in cosmology, such as the origin of the universe. But are there any observable effects that could indicate that our universe is inside of a black hole? Some scientists have revisited a decades-old idea that our observable universe, right now, might exist on the interior of an enormous black hole. That could potentially explain the origin of dark matter and dark energy, as torsion, a property of space-time caused by the black hole, could be the source. According to Dr. Brian Greene, the possibility of our universe being inside a black hole is an interesting puzzle that's been explored by scientists for many years.
First of all, talking about the entire universe inside a black hole is a bit extreme, but what I would say is, it is possible that, at least according to the traditional general relativistic description of black holes, I'm not going to modify it with modern or more recent conjectures, speculations about firewalls and all that sort of good stuff. So let's just act as though Einstein had the important word on black holes, which may not be the case. But if that's true, then right now it's quite conceivable that the Earth just passed across the edge of a black hole, that we are all now inside of a black hole. Why is that? The edge of a black hole, in Einstein's description, is not some special location in space. It's just an ordinary chunk of space that has the unusual property that once you pass that location, the event horizon, you are no longer able to get out. But you don't have any direct physical reaction to crossing over the event horizon of a black hole.
But are there any observable effects that could indicate that our universe is inside of a black hole? Would the universe behave differently if it were inside of a black hole?
So right now, everything, as we look around the world, we could all be within a black hole, and we'll only really recognize that later on when we get closer and closer to the center of the black hole. Because then, depending on our precise distance from the black hole, different parts of the Earth, different parts of our body will feel a different force. If we are going feet first toward the center of a black hole, our feet will experience a greater pull than our head. Our body will be stretched. Spaghettified is the technical term that we use for this process, until ultimately we're pulled apart into our constituent particles that will all rain down on the singularity, whatever that is, the center of the black hole. We don't really understand what goes on there. So in that sense, we could all be within a black hole right now.
Virtually all cosmologists and theoretical physicists endorse the idea that the universe emerged during a single moment some 13.8 billion years ago. That, in a nutshell, is the Big Bang Theory. Evidence supporting the idea is extensive and convincing. However, a few profound questions about dark matter, dark energy, and cosmic expansion have some astronomers rethinking what we know about the early universe.
We currently witness that the expansion of the universe is speeding up, not slowing down. The observations in 1998, culminated in 1998, which won the 2011 Nobel Prize, showed that the distant galaxies are moving away ever more quickly. The expansion of space is speeding up over time. It's accelerating. How do we explain that? The best explanation we currently have is repulsive gravity. We believe even today the universe is suffused with a bath of energy. We call it dark energy. We believe it's uniformly going through space. I like to think of it almost like as a Turkish sauna. It's like the steam filling the sauna, this energy filling space. And that repulsive gravity, we believe, is responsible for the observations that the distant galaxies are rushing away faster and faster over time. So it's circumstantial, but the case for repulsive gravity is quite strong.
Scientists have developed ideas that would explain how the Big Bang emerged as a consequence of the formation of a black hole in a higher dimensional universe. A black hole separates the world in two regions. You have the inside of a black hole and the outside of a black hole, and the event horizon, which you can think of as a border that is always in the distance that you can never reach. No matter at what speed you travel, you will never be able to reach it.
Think about what it then means for you right now on Earth. If you look out into space, there is a horizon very, very far out away, beyond which we cannot see, but we know there's stuff there, but we can never possibly see, and no matter how quickly you travel, you'd never be able to get to it. That's remarkably similar to what you would experience on the inside of a black hole. And it turns out that the mathematics of the interior of a black hole is almost identical to the mathematics of the exterior of the black hole. This edge of the observable universe is getting bigger and bigger. And for example, if you were able to live for, hundreds of millions of years, there would be stuff that would be coming into your view that you couldn't see before. So this is very similar to what you would experience inside a black hole. So the other thing that's interesting about this, right, is that we know that the universe is expanding. And then if you run the clock backwards, like the YouTube slider of the universe, you just run it backwards, right? Eventually that means that everything far, far back in time, everything had to be packed into a tiny, dense little point at some point. And that's kind of similar to what you would expect from a singularity in the middle of a black hole.
Does this mean that our universe, which was born 13.8 billion years ago from the Big Bang, was actually birthed by a black hole from another universe? This could also mean that the black holes in our universe are doing the same thing. Every black hole could be a seed to a new universe.
One of the theories suggests that in the very early universe, it was a highly chaotic environment, very hot, with all the fields fluctuating wildly up and down. And the idea would be that if you wait long enough, on rare occasions, the energy will just happen to flatten out in a region, become uniform, and then that region explosively inflates, grows large. So out there in that wider cosmological landscape, it can be the wild, wild west of realities. This explosive inflation of the region that we currently inhabit, it was just one of many such events. And therefore, there are other far-flung regions throughout this larger cosmological landscape where things have also inflated, but the details can be different. The physical details can differ from what we are familiar with. And the differences can be small, temperature differences in one part of space versus another, or they can be far more significant. Even the particles that make up that other realm may be different from the particles that make up our realm. Their masses can be different, their charges can be different, their fundamental physical features can be different.
Some scientists have proposed that supermassive black holes could act as gateways to other universes, which could contain different laws of physics and potentially even other forms of life. The problem with this hypothesis is that it is highly speculative and we have no experimental evidence. So is there a way to test these hypotheses?
The way you test it is to go into a black hole and find out. That's a one-way trip. I really, really thank you for doing that, but I'm never going to be able to learn what you learned. Second, there's no experiment I can come up with currently that would enable me to distinguish that hypothesis from some other hypothesis, right? So if I say, oh yeah, well, we live in an enormous black hole, part of the equations show me that that's indistinguishable from our current experience, but how am I going to distinguish this? from some other hypothesis? Third, what does it mean for me to contact another universe? What if I have a measuring device here in my universe that works really, really well, like a ruler or some kind of extra device or something, and I take it into another universe where carbon atoms don't exist? The measuring device is useless. So currently, there's not a way for us to even test this hypothesis. So I love these ideas, but I also want ways to be able to test them. However, I am actually excited for the future because I know from history I would never want to underestimate humanity's ability to come up with ways, ingenious ways to test impossible ideas.